Hello and welcome to my YouTube channel. The last time we stopped at sequence types and we saw the three sequence types used in Python, the three categories. So you have the list type, tuple type, range type, and we saw the difference between list and tuple, the immutability characteristic. So today we'll look at mapping type. So the mapping type in this category is only one data type there, and it's the dictionary, which is the dict type. So to create a dictionary, you need the curly braces. Usually the curly braces in other languages scoping, but for Python, it's how you declare a dictionary. So let's make a note of that, right? Let's make a note, okay? So curly. And let me zoom in because I saw with the other videos, okay, I can't zoom in that much. It was not clear. So the curly brace in Python initialize a dictionary. And you might say the dictionary, the tuple, and the list are all collections, right? But what makes a dictionary in some cases better than a list or a tuple? Well, it's searching, right? So in data structures algorithm, which we'll look at in another playlist on the YouTube channel, you'll see why lists are better at searching due to the key value pairs. Okay, so with searching arrays and tuple, you need a loop. But for dictionaries, once you have that unique key, you'll easily access the value. So in dictionaries, can we have a dictionary of dictionaries? Yes, just like with arrays, we have arrays of arrays. Can we have arrays of dictionaries? Yes. Can we have dictionary of arrays? Yes. Can we have what I mean is, can we have a dictionary that contain an array? Yes. And we see it here, like my first list. So let's create our first dictionary. So my snake case, my first dict, okay, equals curly brace. Okay, that's your dictionary. So to create a key, you could use single quotations or double quotations. So first key here, let's call this a string type. So let's call this let's call this my dict string. Okay, str. Okay, and set that to a string. So, or instead of that, let's just call it my name or something, okay? My name. And then set that. So to declare a string, you could do double or single. It doesn't matter, okay? Let's say Elmo, okay? And then comma separates the values, the collection in the dictionary. What if we want to add a array or a list, right? So this array same. So what if we want to have a list in this dictionary? Well, we could create the key. Let's call this my list. And followed by a colon. And then to create a list, you need that operator, the square braces. And then what is the list made of? We could have a list of dictionaries as well, right? But let's do a list of basic the other numeric types, so like 20, 30, 40. Okay, and again, these sequence types are very important because in real world data there's a lot of sequences, whether it's a time based, whether it's time based data, or maybe biological data and stuff. These are made of sequences, so collection is pretty common in programming. Okay, so like dictionary is a good collection with a better search time than a list or a tuple. And then range is for range of numbers. Okay, so let's say we want to add a dictionary here. So my let's call this dict, my dict here. How do we create a dictionary? We need a curly. Okay, and then in this dictionary we would need a key and a value. Okay, so here the key could be let's call this int key, okay, and make this an int, okay. And then if we want to have another key, we could say let's call this floating point key, and then make this a float, okay. So this dictionary, so there's a my dict in my first dict, which is a dictionary in a dictionary, and it has these two values inside the inner dictionary. So this is like nesting, okay. And you might see that sometimes with like server responses and stuff, okay. So let's first try to print this dictionary as is, and then use that type operator that we've mentioned, the type function, and see what type it returns. So my first dictionary, and then type, and then my first dictionary, okay. So this prints both, okay? So here we'll see this part here, which represents this part here, right? So we see the type, it's a class dictionary, and here are the values, which is the values inside the dictionary. So Python will return the values inside the dictionary. Okay, so let's comment out this portion of the code. First, let's copy this portion of the code here. And let's comment out this portion here. And let's practice accessing values in the dictionary. So with this my first dictionary, to access, it's the same notation as the array accessor operator. But in this case, we don't put numbers in, okay? We have to use the key. So the key here, let's say I need my name, we do my underscore name. Okay, and then this will print the value tied to my underscore name. Okay, what if we need to access that list, my list? Okay, so let's do my list. It prints the whole list. But what if we want a specific value in that list? Well, to do that, we'll have to first access the list and then use the array accessor again to access, or the list accessor to access a specific value in this list. And remember that the list is 0 index, so 0, 1, 2. So you have up to 2. If I need 30, I'll do 1. Okay, and it should print 30. Okay. All right. So that's accessing, right? So we looked at accessing on a top level, accessing with these other sequence type being tied to a key inside the dictionary. And also we could look at accessing a dictionary in a dictionary. Okay, so let's practice accessing my dictionary here. So let's do my dict. Okay, and let's first print that key. So it says here int key, float key, right? So we have these keys, so it returns the dictionary, right? So if I need to access one of the keys, I'll use the array accessor operator again. But in this case, it's not a index, which is a integer index. It's a key. So it's similar to the key I used to actually access this dictionary here. So I'll enter this key. So if I need the float value, I'll type in float key. Okay. So now it returns the float value. If I needed the int key, I'll type in int key. Okay, so we looked at creating and initializing a dictionary, which is the only mapping type, right? So we map these key value pairs. And we've looked at accessing these key value pairs. How about updating? What if I need to update the dictionary? What if I need to update the float key? Let's say I need to update my name to a new name, Bert. Okay, let's look at updating. So to update, you call your dictionary variable. You'll use the key accessor using the array accessor and the key name. So my name. And then you'll set that to the new variable you want. Okay, so let's say Bert. So you've accessed, now you've updated. And then let's print the updated dictionary with the new value for that key type. Okay, let's see here, what did I do here? Indentation. Oh, so we don't need any semicolon there. Okay, line 16, print. Oh, indentation error. Okay, so now my name is now Bert. Okay, so my name has been changed from Elmo to Bert. Okay, so you see Python is picky on indentation because that's how it determines scope. Okay, what if I need to update the int key in the mydic, which is nested in my first dictionary? Okay, so let's do that. So we'll call, let's type it out. Okay, so it's my first dictionary. We need that key, which is my dict. We also need the key that we're trying to update. So let's update the int key. And then now update it to the value you want. Well, it's an int key, so we're expecting, let's say 40. Okay. So now let's print again. So print my my first so let's print the dictionary, and we should see the int key move from 20 to 40. Okay, so now, okay, let me comment out this top part here. So we've looked at updating a single variable, and this is like a double access here. Okay, so now the int key is now 40. Let me print the first one here. And the previous key was 20, so 20 to 40. So that's how you update a variable in a dictionary. You have to use the keys to update. Okay, so that's mapping type. So we looked at creating, initializing the mapping type, accessing keys, right? We have top level access, and if we have any more sequence types in there, we could access it. Just keep in mind, what if I wanted a group of int keys? I could have an array here, right? So I could make this as complex as I want. Okay, let's make this 40, 50. But right, so now instead of a int key, we could call this a int list key, right? So it's an integer list with key. This is the key for the integer list. Okay, so if I wanted to access, I would have to go one more level, right? So I would do, instead of int key here, I would do integer list. Let's just update this one. Okay, I could have created a new variable, but it's fine. So my dict, right? That's the key for this first dictionary. It's an int list, and then I need to, let's say I need to update this 50 to 60. So instead of 0, 1, we have 0, 1, 2, so we do 2, and instead of 50, we'll have 60. Well, let's make it 600. It doesn't matter, and we'll see that it moves from 50 lists to 600. So I'm just showing you that you could nest these as much as you want. Okay, you could nest them as much as you want, and the same goes for a list as well, right? So this is 600, this was 50. Okay, so that's creating, initializing, and updating a dictionary. Okay, the other type we have is a set type. Okay, so you have two types of set. You have frozen set and you have regular set type. So these are set types. What is a set? Only unique values. Okay, unique collection, right? So these are stored, unordered collection of unique items. Okay, the set type is mutable, right? Just like with the list type. But the frozen set type is immutable, so you can't change the values in the frozen set. Okay, so let's look at creating the set type. It's the same, right? It's the same as creating a dictionary. But in this case, we don't have a key. We only have values in there. Okay, so this one, let's comment out the dictionary type. And the dictionary type is very popular as well as the set type. So let's do set type. So set type is created. Let me created using the same curly braces or curly operator, right? But no key, right? No key. So let's look at my first set. So my first set, curly brace, no keys. So let's do 1, comma. Let's see if I could repeat values. It says unique, so it should show something here. So let's do that. Let's see what returns. Okay, let's see what returns. So do print. My first set. Okay, let's see what returns here. So we comment out the top code there, right? So we have 1, 2, 3, 3, and what returns was 1, 2, 3. So you see it's only the unique values. All right, so sometimes to make searching faster, you might have sets, right? So sets are good for getting maybe you have multiple keys tied to the same thing. You could have a set of keys, right? And then you get the unique value that matches. Okay, so it helps with searching. So just remember, this one here is mutable. And if I need to make it immutable, I'll call it a frozen set. So let's get some space there and do my first frozen set. Frozen set. Okay, so how do we do frozen set? Well, you need the curly braces. Let me here, frozen set. You need this operator there. Okay, so you need that curly brace. First you need the curve brackets and then the curly brace. Okay, then you could add values. Just remember, no keys, right? These are actual values, no keys. So let's do 1, 2. Let's repeat 3 times. Okay, and I didn't print the type here. So to print the type, you could just copy here and then wrap it with the type operator or type function. Okay, and then you could have this here, and then it says instead of my first set, it's frozen. Okay. Okay, so the first one should say set, class set, and this is tied to this one here. The second one, let's call this like 4. So you see, and 4 1. Okay. The second one is a frozen set, and we'll also print the type here. So let's print the type. Okay. So let's print type here. Okay. Still says set, right? So it doesn't change. So these two, so frozen set and regular set, mutable set, they still are tied to the set type as seen here. Okay, so it's just that frozen set again is kind of like the tuple version for the set here. Okay, and then we have a couple more types here. So the other type that we have is the Boolean type, and you could see these reserved keywords turning blue, true, false, right? So what is a Boolean? Switch, right? On or off. So my first bool, just remember Java is my first bool one. Java is statically typed, so it knows at compilation time what type you have. Okay, so my first, it'll figure out the type. Basically the compiler will figure out what type based on the value you set the variable name to. My first bool 2 equal false. Okay, all right, so these are Boolean types, and if you do print, let's say you print my first bool 1, and then you print, let's just add the type here with a comma here, and then type my first bool 1. Okay, so that's the type there. Okay, so let me comment out the set type. All right, so you see true here prints, class is bool. If I set it to bool 2, which is false, you'll see false here, class bool. Okay, so these are only way you could set a bool type. Okay, you could simulate a Boolean using a integer, right, 1 or 0, or yeah, integer type or numeric type in, well, one of the integer numeric type in Python. Okay, it's only one anyways. Okay, so the next type we have is binary types. So these are like stream, right? If you need a binary stream in some cases, okay, maybe electronic cases. Okay, so how do we declare the byte type? Okay, so we need, so for byte type, you need the keyword. You need bytes, the bytes keyword similar to the type keyword, and then you also need this operation here. So usually the bytes are like a sequence. Okay, so you could say my first byte. Okay, my first byte, set it equal to your sequence. Okay, so if you set it, this one equal, and just to note, these bytes are encoded to the ASCII character set. Okay, so if I do 65, comma 66, comma 67, okay, I need the byte keyword. Okay, bytes. Okay, okay, so you notice it, so bytes that. If I print this one, so let's just do a print here, my first bytes. Let's name this bytes because this is string. Okay, remember clean code, right? Sensible variable names, right? So you could see a B here, right? We didn't have the B here, so it's saying it's a byte stream ABC. What if we need, well, can we access the byte stream? Right? Can we do the accessing? Yes, we can access the value in the byte stream, and it will return the value, not the ASCII encoding. So we can access the byte stream. Okay, so print the byte stream, you get ABC, the ASCII encoding, and we looked at accessing the byte stream. What about the byte array? Same thing, right? So my first byte array, and we need a keyword byte array. We could do the same thing. So 65. Let's do 67, 68. So it should be because the letters follow, right? So let's see. So print my first byte array. Okay, and let's comment out this one here. Okay, right. So ACD. Okay, ACD byte array. So instead of I think the last time it returned B for bytes, here it returns byte array to tell you it's a byte array. Can we access a value from the byte array? Let's do that. Yes, you can access a value from the byte array. It will not be ASCII encoded. It will be the numeric representation of the byte array, the actual value that you entered in there. But for the output here, you'll be ASCII encoded when you print the byte array. Okay, the other one is memory view, and this is mutable, and it allows Python to access memory directly. Okay, so all these memory addresses. Okay, so memory view. So how do we create a memory view? We need the memory view keyword. So my first memory view. So my first memory view equals memory view. Okay, and for the memory view, let's say we do byte hello. Okay, and we wrap. Okay, so let's print. Let me make some space here. When will we need this, right? When will we need bytes, memory view, and so on? Maybe some hardware level coding, right? So maybe electrical signals, bus addresses, and so on. Okay, so that's cases where we might need lower level access here. Okay, so my first memory view. Okay, and we see the memory there. So it's saying this string is at this memory address. Okay, so we have a string, this byte stream, right, at this memory address. Okay, so that's the last type, right? So I thought we finish here. So the last type here is the none type, right? So this is where the data type has no value, right? So there was no value assigned to the type, or a none value was assigned to the type. Okay, so let's look at the none type. Okay, so my first none, let's call this none, my first none equals none, capital N. And you see these are reserved keywords, they turn blue. The functions, they'll have some highlight as well, like the type and the byte array, bytes, and memory view. So this is your first none. If you print my first none, okay, and then we could follow that by the type and do my first none. You'll see here we have this none printed and the class none type. Okay, so that's that concludes all the data types in Python. So we've looked at declaring and initializing all the data types, and we've looked at updating different data types as well, right? So we could update these data types. We could print these data types. We look at the type operator. So I just want to conclude here, right? So this software engineering journey, right? We have these existing tools, right, and desired software. So you're like a mechanic, right? So the first pillar to understand any programming language is the data types, right? So these are the building blocks. It's like the amino acids for coding, right? So you have to understand the underlying data type, whether it's a dynamically typed or statically typed language. Okay, so that's it for this slide. The next thing that we'll look at is typecasting and operators. How do we move from one data type to the other, and what tokens or operations could be carried out on the different data types. Okay, hope I'm making some impact here. Thank you. Okay.